Capacitive touchscreen is the primary user interface used in almost all smartphones and tablets. It serves as both a display and a user input device at the same time, but the limited screen area restricts user interaction. When the user is interacting with their phone, they have unused fingers positioned on the empty space on the back of the phone. We can utilize these unused assets for additional user interaction. Our idea to enable back-of-device interaction is based on an interesting observation. Consider a piece of copper foil attached to the screen. When our finger touches the hanging end of the copper foil off the screen, it still triggers touch events on the screen where the foil is attached. Based on this observation, a simple method for back-of-device interaction is to attach an array of electrodes on the front screen, while connecting them pairwise to the electrodes on the back of the device. Touch events from the electrodes on the back will trigger corresponding touch events on the front screen. The user can also swipe on the back to generate a one-dimensional swiping gesture on the front. However, this design is limited to 1D. One may extend this idea and attach a 2D array of electrodes on the front and back sides. Yet, this would require an exceedingly large number of connection traces and render the front screen nearly useless. Instead, we propose BackTrack, which enables fine-grained 2D finger tracking on the back of the device. We use two groups of electrodes on the back. Each group is connected to a separate 1D array of electrodes on the front. When a finger touches the electrodes on the back, it simultaneously activates two electrodes on the front screen, each in a separate group. The two electrode activations encode the X and Y coordinates of the touch position. To implement this design, we use transparent indium tin oxide or ITO electrodes coated on the thin glass. The ITO electrodes are connected through a flexible PCB to the 2D trackpad on the back of the device. We place it on top of the front screen, just like a screen protector. We engineered a phone case to encapsulate all the components in a clean and compact way. Our system requires no power supply, no wireless or port connection, and no modification of the operating system. Here we show the touchscreen signals produced by our BackTrack system. On the front screen, the top window displays touch events recognized by the touchscreen, while the bottom window displays the reconstructed touch location on BackTrack. When the user interacts with the front screen, it continues to detect touch events correctly, and no back touches are registered. When the user touches the trackpad on the back, two touch events are captured by the front screen. The two events are interpreted as the touch location on the back. In addition, we design a switch to activate BackTrack only when the user wishes to use it. When the switch is released, BackTrack won't trigger any touch events. This prevents the unintentional touches on the back from interrupting the use of the front screen. The switch is fully passive and can be implemented with either a momentary button or a toggle switch. Our system enables various applications. For example, interaction on the backside avoids finger occlusion on the front screen. Here, we build a browser app that allows the user to browse web content by swiping on the back. One can still click on the front to open links. This is helpful to avoid unintentional clicks when we have to swipe on the front screen. Mobile gaming could also benefit from BackTrack. For example, in this shooting game, BackTrack allows the user to control their aircraft using finger motions on the backside. Double tapping can release a bomb that destroys all enemies. Our system can also enrich the front touchscreen user experience. For example, in this file manager, touching the icon on the front screen normally opens the file. However, when the user holds down on the left side of BackTrack, front tapping selects the file instead of opening it. When the user holds down the right side of BackTrack, front tapping renames the file. Last, we use BackTrack as a new way of authentication. When one unlocks the device by inputting PIN numbers, the PIN might be secretly observed by someone nearby. With BackTrack, the user unlocks the device by performing a set pattern of finger gestures on the back. In this case, the action sequence to unlock the phone is tap the top right corner, swipe right, tap the bottom left corner, swipe down, and tap the top left corner. In this way, others cannot observe the back of the phone. Thank you for watching.